Hey everybody, David the AI Guide here. Welcome to another episode. Thanks so much for tuning in. Be sure to follow us on Facebook, Instagram, and Twitter, which I'll fix the Twitter. I got a message about that yesterday. Also, click the link below, get your free AI resource. The resource is free, everything in the resource is free, and it will give you the opportunity to participate in my new beta course, the AI Safe Career Pivot, that helps you change to a career that will be relatively AI safe. And finally, get my book on Amazon, The Beginner's Guide to AI, A Short History of AI, and its current impact on 10 different industries. It's a short read, it's cheap, takes a couple hours to read it. So check that out as well. And thanks again for tuning in. So last time we talked about a major breakthrough that followed up on a breakthrough from only a year or so ago, where a team at the University of Washington headed by Dr. Baker had a year ago created an AI that could take an amino acid string and model a protein from that amino acid string. And this is very difficult work. It would take months to do this prior to that AI breakthrough of about a year ago, TR Rosetta. Now, a new breakthrough by the same team has taken it to the next step, and proteins have what are called functional sites on them. And these functional sites are where medications can latch on, viruses can latch on, etc., to make the protein do something in your body. And keep in mind that proteins control all the biological processes in your body. So this is a major breakthrough, because what this new deep learning AI can do, and we'll talk more about it in 1 second, is find and model the functional site on a protein, which used to take months or years, hundreds and hundreds of trial and error tries to get this to work. Functional sites are the equivalent of a person's hands, where you can grab on, the protein grabs onto something, and these are embedded in the protein structure. And we talked last time about how this new AI is very similar to DALL-E 2, where someone can type in a short string of text and DALL-E 2 will create a piece of art to go with that text. So what they do is they type in the amino acid string and it creates the protein and identifies the functional sites. Amino acids are the letters and the protein functional site is the picture. The idea is the same. Neural networks can be trained to see patterns in the data. Indeed, we know from following this show that that's how neural networks work so amazingly. So they took their previous algorithm, TR Rosetta, which dreams up new proteins, and they altered it to work to find these functional sites on proteins. So when they first did this, it didn't work properly, but then they modified it to their new algorithm that they called Rosetta Fold, and it works like a champ. The algorithm's power comes from its design, modeling each amino acid at nanoscale, providing coordinates to each individual atom. By the way, you need an electron microscope costing millions and millions of dollars to see an atom. So that's the scale we're talking at. Rosetta Fold can predict a functional structure specific to the problem at hand and come up with a sketch of the final design. And then there was a second trick that they use in this deep learning AI Rosetta Fold called in-painting. Here, the team hid parts of the protein sequence and the software had to learn how to decipher information to find these functional sites. In other words, it's a missing information recovery problem. And it works beautifully. So Rosetta Fold can tackle the problems of both building amino acid sequences and generating the backbone and finding these functional sites. So they decided to put it to the test based on known diseases and known vaccines that had already been developed to lock on to these functional sites, and the algorithm predicted it perfectly. And one of the team members, Dr. Ju Wang, his 2-year-old kid got this serious respiratory virus that can cause little kids to die at the exact time that they were perfecting this algorithm, and he ended up using it to design new treatments to treat this respiratory virus. Dr. Wang says, the incident made me realize that even the test problems we were working on, solutions were found that were new, that were quite meaningful to treating the disease. So what does this all mean? It means that it's not powerful enough and not far enough along to actually develop a cure for cancer yet, or a specific cancer, but it is a major step in that process. And based on the progression from a year ago designing a protein to now being able to identify functional sites, I think it's safe to say that a cure for cancer is now on the horizon, solely due to these breakthroughs and the breakthroughs that will come in protein design development, functional site identification, and then treatments for the disease of the protein being modeled. So this is a major, major breakthrough. It's not the final breakthrough, but it's a huge step along the way, because if they can use this AI to find the functional site, the next one will be able to find the perfect treatment to lock into that site and cure the problem. Major breakthrough. Thanks for tuning in. Be sure to click the link below and get your free resource. Also, check out my book on Amazon, The Beginner's Guide to AI, and get the resource right and try out my beta course, The AI Safe Career Pivot, which will help you change your job into something that's relatively AI safe. And what are those? We've talked about it a bunch. Jobs that require the human touch. Thanks so much. I appreciate you tuning in. I appreciate your support. You guys are the best. You're why I'm doing this. And we'll see you next time. Thanks a lot. Take care. Bye.